Hello friends, myself Professor Joshi VM from ADSUL'S Technical Campus, Chas, Ahmednagar. Today we have to discuss on uh, copper saving in auto transformer. Okay, for that we have to draw the connection diagram of single phase or single winding transformer. So let us start the circuit diagram. For that we have to show here one single winding, one single winding and the number of turns of this winding is considered as n, one number of turns, and the current flowing through this winding is considered as I1, and the voltage across this winding is considered as V1, and the secondary winding of single phase transformer is made by using the tapping connection on main winding. After that, we have to draw here load L, and number of turns of winding is named as N2, and the voltage across this tapped winding is considered as V2, and the full winding we will give name as PQ winding, and this tapped winding is named as R. Okay, and the current flowing through secondary winding is considered as I2. Okay, so connection diagram shows single phase or single winding transformer. Input side is shown by P. Input side is shown by uh, P and Q, and the output side is shown by R and Q. Okay, so the R is tap on winding P and Q, and load is connected to Q and R portion. The Q and R portion of winding is common for input and output side. Input and output side. The input side of the transformer has N1 number of turns, while the output side of the transformer have N2 number of turns. Okay, this is a brief description about the single phase transformer winding. The cost of the transformer depend upon the volume and weight of the copper. So the length of each term of winding of auto transformer is considered as L. Okay, then current density is considered as J. The current distribution is shown in figure. The I1 is the primary current which flows through the main winding. So the current from Q to R is called as I2 minus I1 current. Okay. Therefore, the copper volume in each part of the winding is given as copper volume in winding part PR, copper volume in PR part is equals to N1 minus N2 into L into I1 upon J. Okay, then the copper volume in winding part QR, copper volume in QR part is equals to N2 into L into I2 minus I1 upon J. I1 upon J. Okay, therefore the total volume of volume of the both winding is total volume equals to the part copper volume in PR part plus copper volume in QR part. Okay, therefore the total copper volume of auto transformer is total volume of auto transformer is N1 minus N2 into L into I1 upon J plus N2 into L into I2 minus I1 upon J. This is the total copper volume of auto transformer. So we can simplify this equation as 2N1I1 into L upon J into bracket L minus L upon K. Here K is the transformation ratio. K equals to transformation ratio. K equals to transformation ratio. Therefore, copper volume in primary winding, therefore, copper volume in primary winding equals to L into N1 I1 upon J, whereas copper volume in secondary winding is copper volume in secondary winding is copper volume in secondary winding is L into N2 I2 upon J. Therefore, the total volume of two winding transformer equals to total volume of two winding transformer equals to primary volume in copper volume in primary winding plus copper volume in secondary winding. So by combining these two we will get total copper volume equals to L into N1 I1 upon J plus L into N2 I2 upon J. By simplifying this we will get L into N1 I1 upon J plus L into N2 I2 upon J. So by simplifying simplifying this we will get 2L N1 I1 upon J. I1 get cancel. So copper volume in auto transformer we know copper volume in auto exmer equals to upon copper volume in two winding transformer equals to 1 minus 1 upon k. Okay, so the value of k, we know that by the transformation ratio equals to 1 minus 1 minus 1 upon n1 upon n2. This is the value of k equals to, see, by simplifying, 1 minus n2 upon n1. This is the copper volume in auto transformer upon copper volume in the two winding transformer. Therefore, copper volume in auto transformer equals to, therefore, copper volume in auto transformer equals to 1 minus n2 upon n1 into copper volume in two winding transformer. Two winding transformer. Therefore, we will get n1 minus n2 into I1 plus I2 minus I1 into n2 divided by n1 I1 plus n2 I2. Okay, by dividing the numerator and denominator by n2 I1, we will get 1 minus 2 n2 I1 upon n1 I1 plus n2 I2. Therefore, by simplifying, 1 minus 2 upon n1 upon n2 plus I2 upon I1. Therefore, equals to 1 minus, by using the transformation ratio, 1 upon k bracket close plus 1 upon k. Therefore, if we simplify this equation, we will get the copper weight of two winding in auto transformer, copper weight of winding in auto transformer upon copper weight of winding in two winding transformer equals to 1 minus k. 1 minus k So the copper weight in auto transformer equals to 1 minus k into copper weight in two winding transformer. Therefore, saving in copper by using auto transformer equals to k into copper weight in two winding transformer. Cost of copper in two auto transformers is reduced by ratio of n2 upon n1. If the value of k is equal to 0.2, the saving in copper is 20%. If value of k equal to 0.2, then saving is about 20%. Saving is about 20%. If the value is 0.5, k equals to, then the saving is near about 50%. Okay, as the value of ratio reaches close to unity, saving in copper of auto transformer increases. Okay, thank you.